Okay, children. Mm. Today we are going to discuss the aldol condensation, crossed aldol condensation, and Cannizzara's reaction. Now, these reactions mechanisms are related to the carbonyl compounds, and under the carbonyl compounds, you come across aldehydes and ketones, where you study these features, that is the aldol condensation, crossed aldol condensation, and Cannizzara's reaction. So let's start with what exactly is a carbonyl group. And the important thing is that aldehydes which have alpha hydrogens, they undergo self-condensation on warming with dilute or mild base to give beta hydroxyaldehydes, which are called as aldols. And the reaction is called as aldol condensation. So we will go first to understand what are carbonyl groups, what is its nature, and then we will proceed with the other part. So if we are talking about a carbonyl group, then you see a carbonyl group is represented as C double bond O, and this side, these two sides, either you can have the two hydrogens. When you have the two hydrogens, it becomes a formaldehyde. When it has one R and one H, it becomes a acetaldehyde. And when both of them are R's, they may be same or they may be different, then it becomes a ketone. So if, however, we are right now interested in this part of the molecule, that is the carbonyl carbon. Now, if you look at the structure of the compound, then carbon is doubly bonded to oxygen. Okay. When it is doubly bonded to oxygen, oxygen being more electronegative will definitely have a slight, I mean, not a slight, it is being electronegative, it will be del negative, and this is going to be del positive. So the carbonyl carbon becomes a center for attack of the nucleophiles. Nucleophiles are those reagents which are nucleus loving. So a reagent, if you are using a base in these kinds of reactions, the aldol condensation that we will be discussing, then you have a OH minus which is generated from the base. All right, this being a nucleophile is the one which is going to initiate the reaction and form a what you call as an enolate anion, and the enolate anion is then going to attack the carbonyl carbon, which is the del positive. Okay, so let us see how we proceed with that. Now, before we go to that, what is alpha hydrogen atom? Aldol condensation is shown by those carbonyl compounds, by those aldehydes and ketones which have an alpha hydrogen atom. So you must know that an alpha hydrogen atom means the carbon which is next to the aldehyde group or to the ketone group is supposed to be alpha carbon, and the hydrogens attached to that are called as alpha hydrogen. Now, these alpha hydrogens can be lost easily, can be removed easily in presence of a base, all right, whereby which an enolate ion can be formed, anion can be formed very easily. So if this is one of the molecules which is going to undergo the aldol condensation, then you see this OH minus ion from the base is actually going to attack any one of these alpha hydrogens, and since it is negatively charged, this is going to come out as an H plus, and what you will be left with is a CH2, all right, and an OH, CHO. You are left with CH2 and a CHO, and this is going to carry a negative charge. So it is this nucleophile that is going to attack the carbonyl carbon in the aldol condensation process. Okay, therefore the presence of a base is very important. Okay, now let us see what happens. What is the mechanism? Actually, the mechanism is the nucleophilic addition of an enolate anion, that is a hydroxymethyl group, that will be added up. So first we will start with the two molecules of acetaldehyde to understand what is the mechanism and what is going to happen next. So you see, if I am taking, I will represent two acetaldehyde molecules with different colors so that when the condensation occurs, at least you can see the condensation occurring clearly. All right. So the first molecule I will take in red, that is, this is CH3CHO. Mind you, they are molecules of the same compound, that is acetaldehyde. And the other one I'm going to take in blue. So if I take this in blue, so this is going to be, 1 second, this has to be plus, and the next one I'm going to take it is in blue. All right. So let me write this as CH2, CHO. All right. CH2, CHO. Okay. And it is going to have one H here. All right. This H is going to be removed in presence of a base. So you are taking a base, and the ion that is mostly required is an OH minus ion. Now, the first step is what is happening in this reaction and how the condensation will occur. So this CH2, all right, C double bond O and an H molecule in presence of a base, all right, in presence of an OH minus, it's going to remove this H and it is going to form a CH2 CHO. So this is a nucleophile which has been generated in the first step. This is a nucleophile which has been generated in the first step. All right. The red molecule to which this is going to attack is called as the substrate molecule, whereas this is the nucleophile that has been formed in the course of the reaction. So now what happens in the case of CH3CHO? So you have a CH3 molecule, all right, and you have C double bond O and an H. Okay. Now this is del positive and this is del negative, like we have just discussed. It is this CH2CHO negative ion which is going to attack this carbonyl carbon. Okay, so when it attacks the carbonyl carbon, this is going to move here. The pi electrons will move there, and what you will actually get is a CH3, all right, and a C. This becomes O negative, which is going to pick up a hydrogen later from the solvent. I will write this H here, and the next part I'm going to write like this: CH2, all right, and C double bond O and an H. Okay, now you see, this negative charge will further be removed. Why? Because it's going to pick up a hydrogen from the solvent and it is going to form the alcohol molecule. So what you will get here is an alcohol molecule. So this negative charge is removed, all right, and what you will get is a hydrogen is going to be added up here. Now this compound, all right, this is called as an aldol. The word aldol comes from the aldehyde group and from the alcohol group. So you have ald from the aldehyde and OL from the alcohol. Now, right in the beginning, we said the compound that is formed is an beta hydroxyaldehydes. It is the beta hydroxyaldehydes. So why are they called as beta hydroxyaldehydes? Because you see, the main functional group in this aldol that is obtained, the main functional group is the aldehyde group. It is this group. That is, it is this group. CHO group is the main functional group. And if you go by the IUPAC nomenclature, you would start numbering the compound from this carbon, and this would be 1, 2, 3, and 4. All right. So the name of this compound is going to be, the root word is going to be bute. All right. The root word is going to be bute. Saturated hydrocarbon, yes. So butane, al. Why will it be al or 1-al? You can write. Why? Because the aldehyde group is the terminal group, so al. Now it is 3-hydroxy. If you go by the name, it is going to be 3-hydroxybutanal. All right. Now, if it is 3-hydroxybutanal, then why do we call it as beta hydroxyaldehydes? The reason being that when you do the numbering in terms of assign alpha beta values, then the carbon next to the main functional group, this is going to be the alpha group. This is the alpha carbon and this is the beta carbon. just like we said that the aldol condensation is possible only when one of uh, uh, the reactant molecules has an alpha hydrogen. Okay, any one alpha hydrogen should be present. Why? Because if the alpha hydrogen is not present, then it will not be able to form the enolate ion, or it will not be able to generate the nucleophile, and therefore the further reaction will not occur. Now you take a closer look at this molecule and try to understand that the attacking species or the attacking molecule retains its aldehyde group. The attacking molecule retains its aldehyde group. However, the substrate molecule's aldehyde group has been converted to the alcohol group. The substrate molecules aldehyde group has been converted to the alcohol group. So when this is happening, if you look at it closely again, in the previous classes also I have told you that you have to know the mechanism. Only then you will be able to really say that, with the help of isotopes, they will give you different options and they will ask you to select the correct one. Like for example, in this case, if this was O16, all right, isotope of oxygen, and this was O18, all right, then the molecule here, in this case, it is the 16 that is going to form the, because it is the attacking reagent, it's going to be, the aldehyde group is going to have the 16 and this is going to have the 18. Now, when the molecules are same, then there is no problem, because one is the attacking molecule, the other is the substrate molecule. But when the two groups taken are different, then in that case you have to be very particular, especially if you have a mixture of an aldehyde in which one of the molecules is a formaldehyde. Remember, the formaldehyde can never form the nucleophile because it does not have alpha hydrogen atom. Even benzaldehyde cannot form a nucleophile because it does not have a alpha hydrogen atom. So aldol condensation can actually be carried out between two identical aldehydes, meaning aldehyde molecules from the same compound, or it can be carried out from between ketone molecules of the same ketonic compound, or it can be between an aldehyde and a ketone. Okay, so when we talk about the mechanism, there are three steps to it. First is the generation of a nucleophile. Second step is the attack of the nucleophile on the carbonyl carbon. And the third step is the formation of the hydroxy group. Now, these compounds very easily, all right, they undergo alpha beta unsaturation and result in the formation of alpha beta unsaturated aldehydes. All right, that means a carbon carbon double bond will be established. Now, from where will this double bond, where will the double bond be formed? If I have to show the double bond in black, you remember, between the second and the third carbon, between the second and the third carbon, OH and H of this will be lost and a double bond will be established here. That is, a double bond will be established here. So when this double bond is established, hydroxy group is lost, hydrogen from this CH2 is lost, and you get an alpha beta unsaturated aldehyde will be obtained. Okay, so in all these cases, what is happening is that there is a condensation that is occurring between two molecules, and when the condensation occurs, it results in the formation of a compound which has both the alcohol group and the aldehyde group. The substrate molecule has its aldehyde group reduced to the alcohol, whereas the attacking reagent, all right, retains the aldehyde group. All right, so this is between two identical molecules of an aldehyde. Now let's go to what happens when you have this compound and what happens further. Okay. Now, if I go to the next page with the same molecule that we have uh, arrived at here, so I will write the same molecule. So we have the same molecule as CH3, all right, C. This has attained an hydroxy group. This is an hydrogen, and here the H is there, another H is there, then this is C, double bond O, and this is an H. So this is an aldol group. Compound's name is aldol. If it undergoes alpha beta unsaturation, then this water molecule is lost, and the compound formed is going to be CH3C. All right, you get an H here, a double bond. Okay, I have written the whole thing in blue, but this part is going to be in red. So C you will get, and then you will get C double bond O and then H. Okay, so you see alpha and beta. There is an unsaturation between alpha and beta carbon atoms. So this is one aspect to it. Now let us see, is this molecule ready for another aldol condensation? Will it undergo more aldol condensation? Always remember, as long as there are alpha hydrogen atoms, the molecules, the aldols formed will undergo repeated aldol condensation and result in thick resinous compounds, which are called as resins, and it is observed in all those compounds which have more than one alpha hydrogen atom. Okay, so if you look at this compound here, then let me remove this alpha beta unsaturated compound. Okay, and we'll proceed for what we call as the repeated aldol condensation. Now this in presence of a base, all right, this in presence of a base is again going to lose a H. Let us say this hydrogen is lost as an H plus. So the resulting nucleophile that I now have is actually made up of CH3, okay, COH, all right, then it has an H, and then it has a CH and a negative charge here, and C double bond O and an H. So it is this nucleophile which is now ready to attack a second substrate aldehyde molecule. So let me represent that in green. So if this is going to attack another molecule, that is CH3, C, all right, double bond O and an H. Mind you, all the ones that I'm showing in red, blue, and green, they are all acetaldehyde molecules. They are molecules of the same compound. Okay, so in this case, what will happen? This is going to now attack. If I look at the nucleophile, it is now going to attack this carbon here, because this is del positive and this is del negative. Remember, this is a nucleophilic addition mechanism that is being followed. So this is going to attack here. So when it attacks here, the resulting compound that we will get is, you see, you have a CH3, all right, then COH and an H, okay, then you have this carbon, all right, still has one hydrogen which can be lost to form a nucleophile, and in this case this is going to be C double bond O and an H, and on this side it is going to attach itself to C, okay, because see, the carbonyl group has been attacked. So this one will become OH, this has an H, and this side is the CH3 group. You get my point? What is happening is, at least now in this product that has been obtained, this product that has been obtained here, let me remove this. This product that has been obtained here is made up of 3 aldehyde molecules which have undergone condensation. Okay, a fourth one can add up here. I mean, this hydrogen can be again undergo the elimination of the H plus, result in the formation of a negative charge on this carbon, and then again undergo aldol condensation. So slowly, repeatedly, one by one, all the 3 hydrogens of the alpha carbon atom are being replaced by these hydroxymethyl groups, you can say, to form a resinous compound, and this kind of a condensation that is seen is called as repeated aldol condensation. Remember, alcohols are easily dehydrated to alpha beta unsaturated compounds, but you have to either heat them alone or you have to heat them in presence of an acid or in presence of a base. Now the compound in the first step, when we were discussing the compound that we had drawn here, that is the alpha beta unsaturated aldehyde that was obtained from two acetaldehyde molecules, that is referred to as, or that is called as croton aldehyde. That is called as croton aldehyde. All right. So you have these names here, then that is it. Now remember, another important thing is that this repeated aldol condensation is usually seen in presence of a strong alkali, and the dehydration, when it occurs, it results in the formation of the resins. Now you see all these, the red one, the green one, and the other one that will be added on this side, they can all show alpha beta unsaturated compounds, and it is going to result in the formation of resins. All right, so this is the aldol condensation that we know about. Now the condensation is, you can understand, is promoted by the minus I effect, and it is reduced by the plus I effect on the carbonyl carbon. All right, coming next to the reaction, if you look at it in the equilibrium, then it is favorable for aldehydes, but it is not favorable for the ketones. The next that we will take up is a ketone, and the compounds obtained are called as ketols. Now, why it is not favorable for the ketone? The reason being that in the case of ketones, if you take ketones, in the case of ketones, the steric hindrance is a major factor. Why? Because you have two alkyl groups surrounding the ketonic group. That is one factor, and the plus I effect of the CH3 group on the carbonyl carbon. So let's go to ketones to understand. If we are having a CH3, C, double bond O, and a CH3 group, then you check this out. This plus, the CH3 groups on the other side have a plus I effect, and therefore the del positivity of the carbon is reduced as compared to that of the aldehydes, all right, and plus that there is a lot of steric hindrance, and therefore the ketols are not easily formed. In this case, if this has to undergo condensation, then again in presence of an OH, any one of these alkyl groups, alpha carbon atoms, will lose its hydrogen to form an H2O and generate a nucleophile. So a nucleophile has been generated. All right, this is then going to attack the other substrate molecule of a ketone, and whereby which you will get a compound which I can write like this. You have a CH3, okay, a C, O, and the CH3 here. And since this is going to attack, to this carbon, del positive carbon, and this becomes negative because the electrons move to this oxygen. So here it is going to add up, and here you, sorry, here you are going to get, one second, okay, here you will get this molecule added, that is CH2, okay, C, double bond O, and a CH3. This is the ketol group. Why? Because subsequently this substrate molecule is going to pick up a hydrogen from the solvent, and it is going to form an OH group. So you have an alcohol group and you have a ketone group, and the name of the compound is ketol. Okay, again, aldol condensation favors less to the ketones than it favors the aldehydes. So in this case also, due to steric hindrance, repeated aldol condensation may not be seen much, but we cannot rule it out that it does not occur. It does occur, but the thing is that it is going to be at a slower speed, or the amount of product obtained is going to be less. All right, so this was between the identical compounds, identical aldehydes, identical ketones, that is acetone. But what happens when you take two different kinds of aldehydes or ketones? So we will go with the aldehydes only. In the next point, we are going to discuss the crossed aldol condensation. That is crossed aldol condensation. Crossed aldol condensation. Okay. Now let us see what is this all about. In the crossed aldol condensation, I can have two different aldehydes. So I will proceed with two different aldehydes. So let me show you which are the two aldehydes we are going to take. So one I'm going to write in red, the other I'm going to write in blue. So this is CH3 and this is CHO, acetaldehyde. Okay. This in is going to react with, let us say, CH3, CH2, CHO. So this is propanaldehyde. This is ethanal. All right. This is propanal. All right. Now the blue one is propanal. Now in presence of an OH minus, that is the hydroxyl and OH group from the base, NaOH or KOH, whatever you have taken, this OH minus. Now you see, we are not carrying out the aldol condensation by taking just one molecule of acetaldehyde and one molecule of propanaldehyde. No, there are many of them. You know, there are hundreds of acetaldehyde molecules and hundreds of propanal molecules. What this OH minus, when you are adding it to it, will do is, it is capable of forming two kinds of nucleophiles. When it attacks the CH3-CHO group, when it attacks the CH3-CHO group, then in that case, you can see, okay, when it attacks the CH3-CHO group, then the nucleophile obtained is CH2 negative and a CHO. Okay. And when it forms, attacks the CH3-CH2-CHO, then alpha hydrogen will be lost. So the hydrogen from this carbon will be lost. So you will get a nucleophile which is going to be CH minus, CH3 and a CHO. Remember, it is not the terminal, it is not this carbon that will get the negative charge. It is the alpha carbon which will lose the hydrogen to form a CH negative and attach to one side CH3 and the other side it is the aldehyde group. Now you have two nucleophiles. One is this one and one is this one. Now each of these nucleophiles are capable of attacking the substrate molecules which are both containing the aldehyde group. Each of these are capable of attacking the carbonyl carbon of both of these groups. All right. That is the acetaldehyde aldehyde group and the propanaldehyde aldehyde group. Now, when CH2CHO attacks this group, when it is going to attack this CH3CHO, the product that you are going to get after aldol condensation is going to be, the product is going to be CH3, all right, C, OH, and an H, and this group has been added up. So you get CH2, C, double bond O, and an H. So the name of this compound we just did that, it is 3-hydroxybutanaldehyde. All right. Now, when in this case, this compound attacks this propanaldehyde, that means a nucleophile has been generated from propanal and it is the substrate molecule is also a propanal. So in this case, what will be the product obtained be? So in this case, you will get a compound which is going to be CH3, CH2. Now this is the basic, the substrate molecule I'm writing. All right. This is going to attack the carbonyl group. This is going to attack this carbon. So you are going to get C, OH, all right, and then H. And after this, it is this substrate molecule that will be added up. So you will get a CH, all right, a CH3 will come here, and this is going to be C double bond O and then H. Now, you see, in this case, there were 4 carbon atoms, 2 from here and 2 from here. So the name was butanal, 3-hydroxybutanal. In this case, there are 6 carbon atoms, 3 from here and 3 from here. So in this case, a total of 6 carbon atoms are there in the molecule. All right. But if you see the name of the compound is, you will start numbering from here. So 1, 2, 3, 4, and 5. So it is 2-methyl. The name of the compound is 2-methyl, all right, 3-hydroxy. Oh, the hydroxy should have come first. So let me correct that. All right. So the name of the compound is going to be 3-hydroxy. All right. Then 2-methyl, 5 carbon atoms, pentane 1-al or pentanal or pentanal. So the name of the compound is, the root word is pentanal. All right, now I'm writing it here only. It will go off the screen. So this is pentanal. Now, are these the only compounds that will be obtained? No. There are another 2 sets of compounds that will be obtained, because what will happen is that there will be cross connection also. That means there will be a crossed products obtained also. What will be the cross products? You will get a CH3. This is first product that we have written. This is the second product. Now we are going to the third product. All right. Now the third product is going to look like CH3, taking the substrate molecule to be acetaldehyde. All right. COH. Okay. And then H. And the attacking reagent to be the blue, that is propanaldehyde. So you will get a compound which is going to be CH and a CH3 and a CHO. So in this case, you see how many carbon atoms are there? 5 carbon atoms. And the name of the compound is going to be 3-hydroxy 2-methyl butanal. See the difference in the name. This is going to be 3-hydroxy. It is same like the one that we just did. 3-hydroxy. Then it's going to be 2-methyl. 2-methyl. Okay, it's not writing here. Methyl and butanal. All right. Okay, is there a possibility of one more compound? Yes, there is a possibility of one more compound. And what compound is that? In this case, this molecule is going to attack this molecule. That is, this nucleophile is going to attack this compound. So you will have, in that case, if you see, I don't want to change the page because then we'll not be able to see the compounds. So I will try to write it here only. The substrate molecule is now the blue one. So you have the propanal group, CH3, CH2, and it becomes CH and then OH. Okay, and the attacking reagent is CH2, CHO. All right, now in this case, you see it is again a 3-hydroxy compound, but it is a 3-hydroxy pentanal. It is a 3-hydroxy pentanal. Okay, when did 1, 2, 3, 4, and 5? All right. So you get 2 compounds for which the root words are butanal, and you get 2 compounds for which the root words are pentanal. The hexane chain will not be obtained because the CH3 is going to be a part of the branching when the aldol molecule has been formed. So what we understand here is that if we take 2 different kinds of aldehydes, or we take 2 different kinds of ketones, then the crossed aldol products are obtained. The crossed aldol products are of 4 types. All right. How do you know that they are different? When you write their IUPAC names, they will all be different. Okay, like in this case, when I took an acetaldehyde and propanaldehyde, The products that I got were the first one is 3-hydroxy. I'm writing it here because it was a little congested there. So 3-hydroxy, you get butane 1-al, or you can just write butane 1-al or butanal. Okay, this hyphen will not be there. So this is one compound you get. The second compound, when both the propanaldehyde molecules are adding up, then the compound that you are getting is 3-hydroxy. It will always start with the 3-hydroxy. Okay, 3-hydroxy, then 2-methyl pentanal. All right, pentanal. The third product that we got when the cross attack is taking place, that is when the CH3 CHO nucleophile, that is a nucleophile formed from acetaldehyde, is going to attack the propanaldehyde molecule. So in that case also you will get a 3-hydroxy. Okay, so you will get a 3-hydroxy. All right. You will get a 3-hydroxy 2-methyl butanal. 2-methyl butanal. All right. And of course, the fourth one that we got was 3-hydroxy. When the nucleophile from the propanaldehyde attacked the acetaldehyde group, then you got 3-hydroxy. Let us see one second which one I have written. This is aldehyde and aldehyde, acetaldehyde and acetaldehyde. This is propanaldehyde and propanaldehyde. This is 3-hydroxy 2-methyl butanal, and this is going to be 3-hydroxy pentanal. This should be 3-hydroxy pentanal. Pentane 1-al or pentane al. Okay. So we get these 4 different kinds of products. Let me just check if this is what we have done is the same thing that is what we have done here. So this is 3-hydroxy 2-methyl pentanal. This is going to be 3-hydroxy pentanal. This is 3-hydroxy 2-methyl butanal, and of course this is 3-hydroxy butanal. So all the 4 compounds we have written. All right, so this is about crossed aldol condensation. Now the third point that we have to do is about the Cannizzara's reaction. All right, now what is a Cannizzara's reaction? Again, in the case of Cannizzara's reaction, if I take the case of Cannizzara's reaction, Cannizzaro reaction, you try to understand one thing, that this is applicable to those aldehydes and ketones which do not have an alpha hydrogen atom. It does not have an alpha hydrogen atom. So when those molecules are there which do not have an alpha hydrogen atom and they are made to come together, or they're made to react with a base, then what will happen? So in the presence of a strong base, aldehydes without alpha hydrogens, that is, they don't have an ionizable hydrogen at the alpha position, they undergo a reaction which is called as self-oxidation reduction, or you also call it as disproportionation reaction. Disproportionation reaction. All right, this is self-reduction and oxidation process. All right, now let us see what happens. Not much of a mechanism is here. You have an aldehyde group. Okay, now when this is treated with a strong base, all right, OH minus strong base, then what happens is that you start with 2 molecules of this all right, in presence of a strong base, and on slight warming, if you just provide a little heat to it, then or if you are taking very strong base, then also it will show the reaction. One of the molecules will undergo oxidation to form HCOONA, that is sodium formate is formed, and the other molecule will undergo reduction to form an methyl alcohol molecule. That is, one will form an alcohol, the other one is going to form an uh, acidic group. All right, since we are using NaOH, that is why the acid will react with NaOH, and what you are actually getting is a sodium formate. Okay, now this can also occur with benzaldehyde. You see, benzaldehyde is this compound. Okay, this hasn't come out good. Let me erase this. Okay, so this is benzaldehyde. Okay, this is benzaldehyde and it is CHO. If you look at the structure, this carbon is supposed to be the alpha hydro. If this is supposed to be the point in blue is supposed to be the alpha carbon, but it does not have a hydrogen. So this is also not capable or not able to undergo aldol condensation because it does not have an ionizable hydrogen at the alpha position. So this also, when it is treated with NaOH and slightly warmed, okay, this also in presence of OH minus or NaOH you can take two molecules. If you are taking, then this is supposed to undergo, one molecule will form sodium benzoate and the other is going to form the benzyl alcohol, that is CH2OH. So one molecule undergoes oxidation, the other molecule undergoes reduction. However, even crossed Cannizzaro reactions can occur. All right. How will it occur? In the case of crossed Cannizzaro's reaction, let us take the case of formaldehyde. All right. And let us take benzaldehyde. That is C6H5CHO. All right. Will this undergo Cannizzaro's reaction when you're using a strong base? Yes. It is the formaldehyde molecule that will form the acid. It is the formaldehyde molecule that will form the acid, and it is the benzaldehyde molecule that is going to form the benzaldehyde molecule is going to form the alcohol. All right. So this is seen. Now, why is it that the preference of formaldehyde is for the oxidation? Because it's simple. Because in this case, what is happening is that the formaldehyde molecule can be easily attacked by the OH minus ions. Okay. And therefore, it undergoes the oxidation. If I actually look into the mechanism, I'll just show you how it happens. This is HCO. This is formaldehyde. Okay. Now the OH minus ion from the base is actually going to attack the carbonyl carbon here. This is del positive and this is del negative. The electrons will move here. So in the next step, you are getting H, C, H, and then OH. This O has become negative and this has become OH. Okay. All right. Then in the next step, what will happen is, since actually two OH hydroxy groups cannot remain on one carbon atom like this, so this is lost. This is lost as an H plus, and this is going to go and it is going to attack the other molecule, or it is going to attack the C6H5C double bond OH. So this is going to go and attack the carbonyl carbon of carbonyl group, I must say, and it is going to attack the carbonyl group of the other molecule. Whereby what will happen, once this is lost as an H plus, the double bond will be established. If I draw the structure here, the formic acid is going to form like this, and an OH is there, which will of course combine with NaOH to form sodium formate, and this molecule is going to form the alcohol. that is a benzyl alcohol will be obtained. So this is the these are the important points that you have to remember. Now, crossed aldol condensation, can be easily carried out when a proper base is used, and during the reaction, the alpha hydrogens are not present in the case of Cannizzaro's reaction. But in the case of aldol condensation, the alpha hydrogens are the main, the other are the main, you can say the presence of alpha hydrogen is the main factor which is bringing about the formation of the generation of a nucleophile, which then attacks the substrate carbonyl, the carbonyl group of the substrate molecule, and results in the formation of condensation products. And therefore, the reaction is called as aldol condensation. And in case of Cannizzaro's reaction, since one molecule is undergoing oxidation and the other molecule is undergoing reduction, when you are taking molecules of formaldehyde only, or you are taking molecules of only benzaldehyde, and when one is undergoing oxidation and the other is undergoing reduction, then you say that it is a disproportionation reaction that is occurring. Now, one last point that I will like to point out here is that if will a aldol product undergo Cannizzaro reaction? Okay, will an aldol product undergo Cannizzaro reaction? So let me go to the other page and I'll just show you something here. Let me go to, okay, let me go to this page again, and you see here, in this case, there is repeated aldol condensation. Fine. So in continuation from here, if I go to the new page and we discuss this here, till there you have understood that a molecule can undergo repeated aldol condensation and it can form, okay, if I show this in blue, all right, then this is C double bond O and then H. And then one of the groups I will show here as C, okay, which is attached to a CH3 and is attached to an OH and an H. And one of the other groups I can show from this side, that this is C, which is attached to a CH3 and OH and an H. Okay, you see, this is the nucleophile which has undergone repeated, the alpha hydrogens have been repeatedly ionized, and this compound has been obtained. Now, if you look at this compound, this does not have an alpha hydrogen atom. So when this does not have an alpha hydrogen atom, no alpha hydrogen atom is present, then this, in presence of formaldehyde, it can undergo Cannizzaro's reaction. All right. It can also show the Cannizzaro's, the products obtained from Cannizzaro's reaction. So let us see what will happen if this has to react with, let us say we are taking a formaldehyde in this case. All right. So you see, in this case, if it is going to react with the formaldehyde, let me show the formaldehyde in black. All right. If this is going to be HCHO, then remember the formaldehyde molecule is going to form the acid, and this compound is going to form the alcohol. All right. So in this case, if this is undergoing Cannizzaro's reaction, now this is a little bit too much for standard 11 and 12 to understand, but still we'll do it because it's interesting. You see, this, in this case, it is going to form HCOO negative plus and minus. All right. But the other molecule that will be formed is going to be the same one. I'm going to write it like this: R for this R, C, OH, and an H. The R represents the R, the red color represents the molecule that is there. This is C, all right. And this is also going to form CH2OH, okay. All the attachments will have the alcohol group. This is CH3 and it's going to be OH, and this one is also going to be C, CH3 and an OH, and an H is there and an H is here also. So you see, this has undergone reduction to form the alcohol, whereas it is the formaldehyde which has undergone oxidation to form the sodium formate. So whether you have 1, 2, or 3 alpha hydrogen atoms, if they are containing 1, 2, or 3, depending on that, if the product obtained, aldol product obtained, does not contain an alpha hydrogen atom, then it can also undergo Cannizzara's reaction. Now, why I am explaining this is because in your joint entrance exams, they may give you compounds which look like this, and it's an aldol which has been formed, and they will ask you whether this compound can undergo Cannizzara's reaction or not. So you will be able to say yes or no. If you know that the aldols obtained after the products have been formed, then it can show Cannizzara's reaction. Now, this was a compound with 3 carbon atoms. All right. This aldehyde was containing this carbon. This is CH3CHO was containing 3 hydrogen atoms. So the 3 products are formed. Sometimes you can also have, compounds like, just the last bit, you can have a compound like, let me show you in black. Okay, you can have a compound like CH3 whole 2 C. Okay, and it is just containing 1 hydrogen, and this is the CHO. This will be able to show only one. It can generate only one nucleophile attack, and the compound obtained in this case is going to be CH3 whole 2 C. All right. Then in this case, it's going to be CH2OH, and of course, this is going to be one of the molecules is going to be CHO. So you see, now in this case, this carbon atom is now not having an alpha hydrogen. So this can undergo Cannizzara's reaction. Suppose you are taking a HCHO, then this is going to form the acid, and this part of the molecule will form the alcohol, and of course the compound Cannizzara's reaction will be shown by the compound. So this is all that I need to tell you. Too many things we have done today regarding the aldol condensation. It is not an small topic actually. You really need to understand the mechanism to be able to answer questions related to this aldol condensation. However, still, if you have any doubts, or if you have any questions, queries, you can always ask. All right. And let me see one more thing here. Okay, so if I go here, all right. Okay, children, so I think this is all for today. It was a long class, longer than the time I expected, but anyway, we have done the aldol condensation, Cannizzara's mechanism, and of course the crossed aldol condensation. So thank you, children, for today.